So let's look at the relationship between position and actual function s of t, velocity, v of t, and acceleration, which we'll call a of t. So position, we'll think of an object thrown up into the air or something launched from a cannon or a particle moving along in space, like horizontally along some line. We can calculate its position at some time. And so let's say we have s of t equals t cubed minus 3t squared plus 5t minus 7. Okay. The velocity we're going to think of as change in position over change in time. So velocity is simply the derivative of position, or the rate of change of position with respect to time. Thinking about what derivatives are, it's some rate of change. So velocity will be 3t squared minus 6t plus 5. And then for acceleration, that's how velocity is changing. So am I accelerating, am I decelerating, am I speeding up, slowing down? So that's going to be our acceleration, which is simply the derivative of velocity, or what's the rate of change of velocity. So velocity is the derivative of position, and acceleration is the derivative of velocity. I'm looking at it the other way. Suppose we have, so if we had the position function, we can use derivatives to find the velocity function and the acceleration function. Well, what if we know the acceleration function? How can we find the velocity and position functions? Well, we know that velocity is the derivative of position, and acceleration is the derivative of velocity. So going backwards, using integrals, we know that velocity should be the integral of acceleration. So we said, what is the integral? That means, well, if I take this function here and find its integral, that means this function is the derivative of this function. And we know that to be the case. Acceleration is the derivative of velocity. So if we know acceleration, we can find velocity by finding an integral. So velocity is going to be integral of negative 3t plus 2 dt, which is negative 3/2 t squared plus 2t plus our constant. You want to check 2 times negative 3/2 is negative 3 times t. Derivative of 2t is 2. Derivative of the constant is 0. Now, how do we find that constant? This is where we use initial conditions. So let's say we know that the velocity at time t equals 6. Okay, so this allows us, so if this is the velocity function, that means velocity is 6 when t is 4. So we just plug 4 into the function and we solve for c. So 6 equals negative 24. 4 squared is 16 times negative 1.5. It's negative 24 plus 8 plus c, which gives us c equal to 22. Negative 24 plus 8 is negative 16 plus 22 is 6. So we have our velocity function based on this initial condition, 3t squared, negative 3 halves t squared plus 2t plus 22. And now again, since we know that velocity is the derivative position, that tells us that we can find the position function simply by finding the integral of the velocity function. Again, because by definition, if this is the derivative of that, then the integral of this should be that. So s of t, we can find the position function by finding the integral of the velocity function. Which is going to be negative 1/2 t cubed plus t squared plus 22t plus constant. So, and again, checking, we have 3 times negative 1/2 is negative 3 halves t squared. 2 times t to the first plus derivative of 22t is 22, constant is 0. And then to find the, suppose that at time t equals 0, position is 0. That would give us a constant of 0. And so the position function is simply that. We have position function and velocity, the derivative position. Acceleration is the derivative of velocity. So starting with a given a position function, we can find the other two. And going backwards, if we've got acceleration function, velocity is the derivative, or the integral, sorry. The integral of acceleration will be velocity, and the position function will be the integral of the velocity function. And in the case of finding the integrals, how we will find the specific velocity and position functions, we will use initial conditions. So if you're given an acceleration function, you'll also be given initial conditions. For some particular time, you'll know the velocity. For some particular time, you'll know the position. Those you'll be able to use to solve for your constant terms after finding these two integrals. So there's the relationship between position, velocity, and acceleration.